Hi, this is Joseph Manta, the Nashville Mobile Development User Group. It's August 25th, 2015, and this is our monthly meeting. This month we're talking about BLE, iBeacon, Eddystone, and the physical web, and our presenter is Zenerino. I'll introduce him right now to the group. Hey everybody, I'm Joseph Manta. I'm one of the organizers of this group. We meet just about every month to talk about development in mobile and kind of anything not desktop, and sometimes that even branches over into service development and whatnot, database. But usually it sticks to mobile. We are a Google-sponsored user group, a Google developer group. So we take sponsorship from them. That means we get some goodies from them sometimes, and we have some early insights into their upcoming technologies. So, if you ever want to hear about anything, or if I can do anything for you with Google, I've got some contacts, and they've come in handy with some people in the past. Today we're going to be talking about BLE, iBeacon, Eddystone, and the physical web. Our presenter is Mr. Zenerino. I have a couple of slides I want to show before we let him go. Obviously, you got here, so we don't need this one. Every month, big decision is the food. I know this is kind of superfluous, but I'm going to go through it anyway. We've had people ask for things from sushi to barbecue, and we do what we can to provide. When we get 36 RSVPs, we got to go cheap. That's pizza. So that's what we did today. And, it's the best. It's Jets. I like it anyway. Looks like we didn't get enough vegetarian pizza, and apologize for that. Future events, there is one coming up in just a couple of days this weekend. It's Music City Code. It's down at the Lipscomb Swang Business Center. I've not actually been there, but I plan on attending this conference. It looks to be good ones. There's a few good presenters speaking on it, and I recommend you check it out. In less than a month, this user group is going to be hosting a Google Project Tango hackathon. Project Tango, if you're not aware of it, is a tablet-sized device that can sense its position in 3 dimensions, and it can know when it's moving with 6 degrees of articulation. So being able to construct or reconstruct a 3-dimensional model of the space that it's in, it is capable of tracking its own motion in an environment, and that's useful for all kinds of augmented reality applications, virtual reality, etc. But we're going to be having this Tango hackathon on Saturday, September 19th. That's going to involve people coming in. You don't need any Unity experience. I would recommend having some Java experience. You don't necessarily need Android, but it would help. If I get enough people to sign up or RSVP for it that don't have any Unity experience and kind of would like a Kickstarter, we'll probably have something the day before or maybe really early that morning, get people started. But we'll definitely give everybody a hello world to start with. A working project to do anything that they want to start out. We're going to recommend that everybody come with a team of 5 members. If you don't have a team, we'll put you on one. You don't need to be a developer, because every team is going to need somebody to present. Every team would like a designer, somebody that can draw up what the app should look like when it's done. At the end of the day, the hackathon is going to culminate in a series of presentations, and our celebrity team of panelists is going to judge the winner, and the winning team is going to take home 5 Tango devices. Unless the team isn't comprised of 5 people, then we'll figure out another way to give away the extra ones. Maybe the second place. And by the way, breakfast, lunch, dinner, you're taking care of for the day, and it's down at Emma. If you don't know where that is, just ask me later, and I'll put you to it. It's down where the trolley barns used to be, if that means anything to you. October, we're hoping to have a really fun, what seems to me like a fun meeting. A cage match. We did this last year. It was Android versus iOS, and we had some really good speakers on there. It was probably one of our better meetings. And there were no winners. It's all friendly. But we had some some really good, knowledgeable people come and talk about their chosen platforms. This particular one, we're talking about mobile development, native versus mobile versus hybrid, which is JavaScript and PhoneGap or Ionic, whatever your chosen hybrid is, versus framework with Xamarin. You can call Ionic a framework. I don't know if that's a framework or if it's hybrid or what. You know, we're going to be looking for experts to volunteer on this and come speak as to their favorite chosen platform, because I think every one of these merits having a champion. And anyway, we'll be chirping about this and tweeting and all that in the next couple of months, and hopefully we'll get some really good people. Oh yeah, after that, if you have a topic that you think is pertinent to our purview, mobile development, if you want to present, if you want to help organize the group, if you have an alternative venue, although we're pretty good with this one, we don't really need an alternative venue. Talk to me, us. Zach is also one of the organizers. Raise your hand, Zach. I'm Joseph Manta. I work here at BMI, so we're good here for now until I take somebody off, which is, you know, every other week. Just talk to me at the meeting if you have an interest in participating in an administrative role. I think with that, we can just get on with the presentation. And hopefully, pushing this button will do something. Yeah. All right, Mr. Zenerino, take it over.
Yeah, so I'm going to talk about strategy, iBeacon, Eddystone, and physical web. My name is Zenerino. I know it's spelled B, but it's pronounced just a little different. So anyway, I do answer both pronunciations. I wasn't quite sure what the knowledge level of iBeacon or Eddystone was doing, so I wanted to put together a little bit of a presentation on hardware. So the first part is going to be some hardware centric, and then go over iBeacon, which is basically iOS. And so it's some code snippets from iOS, and then more iOS Zenerino. The Eddystone is the one that Google came out just a few weeks ago, a couple of months ago, and that's more Android. So I hope it's going to be in the physical web, which is actually neither one, which is browser centric. So it's, there's going to be something for everyone. And just let me know if, well, obviously ask questions anytime during the presentation and whatnot. So beacons, right? iBeacon was introduced a couple of years ago by Apple, and it's going to be touted, you know, the really cool thing, the next big cool thing and stuff. And we've seen a lot of talk about it, and it's going to do all kinds of different things for, you know, proximity marketing and checking coupons, pushing coupons to everybody, and you know, some of the location stuff, and maybe contactless payments. And although contactless payments now is, you know, taking over by NFC, and maybe using Samsung Pay. I don't know if you guys saw it, but it actually can access a card itself, which is kind of cool. But so there's other solutions for some of that stuff, and people, you know, many organizations have used beacons, some with success, some without success. But anyway, I'm not going to go into any of the applications of beacons, you know, how you can then apply it. So I'm going to go more into the technology of the beacon itself, since it's not really a marketing presentation. It's about proximity, right? So beacons are, GPS is location-based, right? If you have a GPS on your phone, it can tell you where you're at in the world, anywhere, right? Beacons is more proximity, so you're getting close to an object, and you're getting close to a beacon itself, which is there's a lot of overlap there, right? So if I place a beacon somewhere and I know the exact location, then if I get close to the beacon, then I know where I'm at too. But of course, beacons, you can wear a beacon on your keychain or something. They're really small. I did bring a few beacons. This thing is really, they can get even smaller, so you can wear them yourself. So the beacon actually then travels with you anywhere. Maybe links to your LinkedIn profile or something, right? And so it's not locational always, right? It can be proximity, or it is proximity. So it's beacon technology itself is really simple. It's so I have a Bluetooth energy device that just sends out the data stream. It kind of like every second or every half second. It sends a number basically. It sends out the number to the phone is constantly listening to BLE traffic, Bluetooth traffic around it. And then once it sees a beacon, and it sees a beacon that transmits the number 2, then it knows I'm close to beacon number 2 at that point in time. I can either do something on my phone itself, right? Either have a local table or something, or I can go to the cloud and grab something maybe more time relevant. So that's really basically it. We just kind of set numbers, and so we're going to go into first we're going to go into the beacon, the hardware, and this is the one that I have right here. And there's a battery on the back. I don't have a picture of the battery on the back, but the hardware itself, it's basically it's one processor that it's manufactured by Nordic. Most everybody there, TI makes one as well, but most beacons use the Nordic chip, and it's a system-on chip, so it has a 32-bit microprocessor in there. So it's an ARM processor. It's better than an Arduino, but not quite as nice as a Raspberry Pi, right? You can definitely write some ARM code on there. And also in the chip itself, it has some radios in it, so it's just like it's one chip and it does everything. So all you got to do is put a battery on the back. Or maybe put in there are some external components to resistors and stuff. You need a crystal for it transmits in the 2.4 gigahertz space, so it has to be fairly accurate, pushing out the data. And then 32 pillars crystal to timing over seconds and stuff. So, and then of course you have the antenna. So this is just a simple little trace antenna. So it's right on board there. So there's really most of the cost is just like this chip. Everything else is supported with the chip. So they can be manufactured pretty cheap. So I'm sure, you can manufacture these for millions with hardly any cost. And we will see these other things quite a bit. So we're going to go with the Bluetooth protocol a little bit first. The phone actually, how the beacon communicates with the phone, right? It's so it has a radio, has an antenna, it sends out signals, and it has 40 channels. It's in the 2.4 gigahertz. It has 40 channels, and it's basically like an FM radio when you switch to a different channel. So each beacon can broadcast at a different channel, or you can tune into a different channel. And
wait, how do you do that? How do you tell it what channel?
It does it itself.
Oh, really?
Yeah, right. It's basically a stack. So that chip that was on there, they sell the stack that goes in there. So the chip comes with the whole software that does it automatically, and then the phone has it all built in as well.
So it just like I guess you could say it just scans and sees what it picks up then?
Right, yeah.
The phone scans and to see what this thing is doing.
Right, exactly. Well, so you have the 40 channels, and so before you connect to a beacon, you actually don't connect to a beacon, but like a regular Bluetooth energy device, like a Fitbit or something, how you connect this, the Fitbit sends out advertising packets. So basically it makes itself known that, well, here's a Fitbit, and then the phone, and these packets only go out on these channels, 37, 38, and 39. So the phone only scans for those channels, for those 3 channels. Then once it's connected, it starts actually using the other channels. And every time there's data coming, it goes to a different channel, so you can like tune into one channel and get all the data from. So there's a lot of security built into. You can't just get all the data because it's the first part of the data might send at channel 4, the next part at 6, and you don't even know which one. So if you're listening to, from a sniff or a scanner or something, you don't really know. Do you have a question? Oh, yeah.
Oh, yeah. So all the information for one device isn't just on one channel. Because I was wondering, like, if you had 41 beacons like right next to each other, would they not work anymore?
No, they would.
It would, because
Actually, beacons only use those 3 channels, 37, 38, and 39.
okay.
So they're only advertising. All the other channels is once you connect to something. For beacons, you don't really connect to a beacon. It only advertises itself to what you are.
So wait.
Well, plus it's hopping. So even if I have like 100 Bluetooth low energy devices in here, each one of them would like constantly hopping between the Bluetooths.
How does it know?
There is a table, so that when they connect first, they exchange the table. So it's like the table before the entries, and the one that have ones in it, it actually then transmits on those, and then it goes up to the thing, and it goes back around. And it sends that, before it starts hopping the channels, it sends the whole table to the phone, so the phone knows, or the other way around, the phone sends it to them. Yeah. Right, and so, yeah. And there's some dynamic, right, you don't have to do any of that. There's some dynamic if there's like a lot of noise in one of the channels, it won't take that, and maybe take some other ones or something. So there's a lot of dynamic stuff going on in the energy that just hops around and stuff. And actually, those advertising channels are picked, they're in these spots. So these are the ones that the beacon uses to advertise itself. And they're actually picked for a reason because the wireless, like your Wi-Fi network, is like there, and there, so there's 3 channels. So it's right outside of the Wi-Fi. So once it connects, it starts using the same frequencies as Wi-Fi, but before that, so you have less interference. So the link layer, so that's how Bluetooth devices use the frequencies and use the radios to talk to the phone, but then there is of course there's a whole protocol behind it. So then you have to so you don't have to write your whole protocol, right? So there's already an existing protocol. And BLE Bluetooth energy is much simpler than the old Bluetooth, where you have the headset and stuff like that. One of the reasons it's no energy is because it's fairly simple, and the processor doesn't really have to do a whole lot. But it only has, I guess, has one packet format and 2 types of packets. So there's an advertising packet, and that's really what iBeacon stuff is and Eddystone. And then once you connect it, once you advertise, and then you get the connection going, then the data packets come into play. But yeah, Bluetooth energy is actually totally different than the old Bluetooth. There's some common things, but it was developed independently. So right, so device discovery. So 2 devices. How do 2 devices discover each other? So I have a Fitbit or a phone, or I have a beacon on the phone. So the advertising packet can only transmit 31 bytes. So it's not a whole lot. And that happens like in 7 milliseconds. So it's very fast. It's almost over before we know it, right? And so that's another thing about about low energy. So holds up the radio for 7 milliseconds and shuts down the radio, so it can last like one of those batteries can last for about 6 months. The small one. So, and so there's not a lot of data that you can put into. So there's not a lot of protocol data. And so the beacon right there. So both of these, I don't know if batteries and the bigger ones, but these small beacons that just send out the little signal, little advertising signal. Like we think these like every half a second, we just send out those 31 lights, and that's it. And so if your phone comes close to you and picks up the signal, then it detects that it's there, right? And so more details. So it's maybe confusing at the beginning, but so this is the beacon. So and it advertises, this one advertises 20 milliseconds, which is a lot. Beacons usually don't go that fast, but it's just every 20 milliseconds it sends out these signals. And then the phone scans like the channel 37, 38, 39, and that's depends on the phone, right? How often they scan and which channels they scan for. So, of course, the less they scan, the less the phone scans, the longer your phone battery lasts, right? So each phone manufacturer probably has maybe their own secret little formula or something to extend battery life. So if you don't scan enough, then you're not discovering the devices fast enough, and if you scan too much, then your battery goes down too quickly. So, but advertising is, channel 37, 38, 39. And then the protocol layer, so you're just your exchanging data, right? So Bluetooth energy is about data. I mean, that's pretty much what it is. And to make it really simple, each data packet, instead of having like a hash with names, you say first name, and it's your first name and last name. Each data packet has a 128-bit classifier, right? So you don't name, you give it a number, right? And the Bluetooth 6 special interest group has defined some short ones, so you don't have to use that 128 numbers for everything. But it's basically all the handle, but then you have an attribute type and an attribute value, all the value. But then, so that was the attribute. Then you can, the next step up is GAP, which is the generic attribute profile, which actually iBeacon doesn't use a whole lot, but it comes into play later with Eddystone. So basically, it takes all these attributes and makes a hash, and you can create a hierarchical hash with the GAP protocol. It has some definitions how you can make it hierarchical. So with Bluetooth Energy has services, just like actually the old Bluetooth had services as well. So I can have a battery service. So whenever I see the number, these are defined by the special interest group 18OF. So whenever I see a service, it advertises me a service and it's 18OF, so I can query the beacon, or I can query the Bluetooth energy device with that number, and then now I'm going to get the battery state. So so these are all defined, predefined, already deleted alerts. So actually, you can write your own app, like an Android app, that scans, and you can see that number, and you say, oh, okay. Even though you know nothing of the device, but if you see that number, you know it's a battery service, and you know you can get the battery state of that, or you know you can get a hot rate from that. So it's so they're predefined numbers. But then also, if you define your own, obviously you can define your own services, and you have to use the 128-bit numbers. And that's actually, and next I'm going to get into that. Then we have characteristics, so each service has a characteristic, has a set of characteristics. So maybe the device information service has a manufacturer name, model number, whatever. So you can get a whole hierarchy, right? So you can, with different, with the GAT protocol. Yeah, this is a little abstract, but we kind of set up a service and have different two characteristics for the service. There was a proximity tag, and then have a primary service called TX power, and then the characteristic is power, and then the value is actually given there. So you create this whole hierarchy, but that's about it. That's all there is to Bluetooth for energy. That's like the whole protocol. For exchanging data. The other one, there is a slightly different protocol. Well, we have the advertising packet and we have the data packet. So this is an advertising packet, and GAP, the generic access profile, defines how two devices connect to each other, how two devices find each other. And we already looked at the hardware side on how frequencies, and this is more of the profile. So it defines device discovery, and beacons are really just about discovery, right? So you walk into somewhere, you walk into a mall or something, there's a bunch of beacons there, and all you want to do is really discover where the beacons are. You don't connect to really the beacon, you just want to discover the beacons. GAP2 does define two roles, the central role and the peripheral role. The beacons are in the peripheral, and the phone is in the central role. So that's another aspect of Bluetooth Low Energy is all of the heavy lifting is done inside the phone, so which uses your battery on the phone, but it allows a Bluetooth Low Energy device to be low energy. So and of course the central phone can connect to many different devices, and it scans fairwave, does most of the work, uses most of the power. And then the peripheral, and those are central and peripheral, those are really, you're going to get into those in Android, iOS and Android as well, right? So actually, Android, you can only be central, like up until the latest version of Android. I think 4.3 and 4.4. You can only be essential, and now with 5, you can actually be peripheral as well. So that's something new to add. So you can make your own. You can make your phone into a beacon basically. So you can be the beacon. iOS had it for a while. Right. So the defines the advertising data format. So the advertising data format is 31 bytes. So there's really not a whole lot of space in there, right? And how are you gonna communicate something like some information? So you only have the length byte. So the length is 1 byte. Then you have the advertising data type, which is predefined by a special interest group. Then you have the data. You only need 1 byte because it only has 31 bytes. So length, you don't really have to find more bytes than that. But so I have that's maybe a little hard to see, but I have a tool at home where I can intercept traffic between two Bluetooth Low Energy devices. This is kind of a scan of what it looks like. And I can see the packets. It also gives me a timestamp of so you can debug some of it. It gives me a timestamp. It gives me the channel. Channel is 25x, which is 37, I guess. So it uses the advertising. So it always uses the advertising channel 37. And this stuff, and there's some other headers, and most of this I don't really know what it's about. The interesting thing is here, the advertising data. So And the advertising data, that's what GAP defines. So have a better look at that. So we had a length and flag, well, we had length, and then what it defines. So the length, the first byte is, and this is just the data that the beacon sends out on the advertising packet. So every half a second it sends exactly that. So that just sits there, year after year, just spits out these bytes, right? And the first one's like, it defines, these are flags, they're just special flags, don't really have to worry about that either. And the other flag data 6 means something, I don't know really what. But then the next one is, so length is 26, so it's basically 26 characters long. And FF means that anything coming after this is proprietary to some manufacturer. So you can apply to a special interest group and they give you a number. So Apple applied to the special interest group and they gave the number 004C. And so we know now that 004C, so we know that any data after this is Apple specific, right? And yeah, actually, Apple and Bluetooth, and CoreBluetooth, Apple actually takes out all of this information, never gives to you because it's specific to Apple. So they think that in Android you can scan all of this data, and we can get into that. But so right. So now what's all this Apple specific data? And well, quick recap. It's fairly simple. Beacon sends advertising packets every half a second, every second, however we want to define it. The phone listens for the advertising packets. And beacons do not connect to phones, only when you configure, like if you want to configure a beacon, you want to change the transmission power or the advertising rate or something. Yes?
Is the phone listening for packets at like the OS or the API service level, or is it like you actually have to build that into an app and have it installed for it to actually be listening for these packets?
On Android or both?
Either one.
No, it's at the system level.
So even if I don't have any apps necessarily that know how to do anything with it, my phone's still scanning for beacons all the time.
Well, that's a good question. Obviously, I don't know what Apple's doing. If you have Bluetooth turned on. Yeah, good question, probably. Maybe not as frequently as yeah. But, yeah. Of course, you don't know, because you don't really, I guess you could probe the chip or something. See if it turns active or not. But yeah. Right, but yeah, if you have an app and you actually ask the OS to look for these, then it's going to scan. Otherwise, what it does, I don't think Of course, now that Facebook uses beacons, so the Facebook app probably listens to beacons constantly. But, all right. So, first the iBeacon protocol. iBeacon protocol is Apple. It's proximity based. It's proprietary, so you have to sign up. If you actually want to know the details, a lot of people have reverse engineer, obviously, but if you do want to know the details, you actually have to sign up with Apple with a special, the MFI program or whatever, and pay them some money or something. So, it's Apple proprietary, right? So usually, we have some iOS developers, right? And to interact with Bluetooth devices, you use CoreBluetooth, right? You can connect, you can scan for Bluetooth energy devices, you can connect to Bluetooth energy devices. But iBeacon actually uses CoreLocation. So, and the iBeacon itself, so if I have a beacon that's an iBeacon, it advertises a set of numbers And so, well, in my first example, I just gave, I was just like, well, what if the beacon advertises the number 2 when you come into contact and you see, oh, it's beacon number 2? Well, that can get a little bit out of hand, right, if you only have like one number. So iBeacon defines these three, the UID, the major and the minor. So the UID is basically there to, so the beacon that belongs to you doesn't interfere with somebody else's iBeacon, right? So it does say it's a universally unique identifier, but it's not each beacon doesn't have like a different UID. You just generate one, with one of these programs. You generate a UID, and that's what you use for all of your beacons. So if I see this UID, I know it belongs to somebody. But then you can have the major and the minor. You can define that. So these change. Each beacon has like different major and minors. They can have all the same major and minor. That's really up to you too. But you can use these to just to define different things. I always thought it was kind of silly just to give you like two different levels. What if you have like 3 different levels of hierarchy or 4 different? So you gotta fit into the major and the minor. So maybe a major can be a city, right? And the minor can like signify all of the beacons in the city or something. And this comes out of the getting started with iBeacon. So you have one UID, all of your beacons in San Francisco, Paris, and London, they all have the same UID. But then the major signifies the city, and then the minor signifies, which department in the store or something. So it was kind of an example into that. But you can really do whatever you want with the major and minors. You don't have to use the major, you don't use the minor. It's just numbers that you can use. I mean, there is some significance to those numbers as far as programming in iOS. So I have a screen of a program that scans for beacon. So this program now found the beacon, and iOS said that, oh yeah, this beacon has this UID as a major of 1,000, minor of 500, and I can. So if you go back to whatever the iBeacon sends out, we've seen that this first part is kind of just some flags and stuff, and then it says 0014, that's Apple stuff, and so all of this Apple stuff comes. So if you look at traffic coming from an iBeacon, you can then actually get the UID, the major and the minor, out of the traffic. So you can see all it does in those 31 bytes that it sends out, and iBeacon sends out, you see the major and minor and the UID. So that's basically the whole program. So it's 31 bytes every half a second, every second, and that's those are the numbers, and that's basically iBeacon. Right?
Hey Ben,
Yeah.
what's the last number do?
B8.
B8 is used to figure out the distance. It's in RSSI. So it tells you how strong the beacon sends the signal. So it can then it can take the strength of the receiving signal and take the strength of the of the sending signal and do a calculation between those two number and amount approximate distance. Yeah. Yeah, that's actually. I mean, these are really easy to reverse engineer these numbers. The last number, these people that figure out what it meant, but it's proprietary. Yeah.
So how do you assign significance then on the major and the minor? Like who does that, like the city and the store?
You.
Okay. On the device itself? I mean, how do you do that on the device itself?
Right, yeah, there's apps. Each beacon manufacturer has an app that you can program.
Okay, that's what you showed up the previous one. All right, so something to do with that.
Yeah, right, actually, that's one of the apps. I can click on this one and then I can put in another number. And then it programs the beacon to this other number.
Or so the numbers are already assigned something, and then you just put it in.
Applications.
Yeah.
You assign it,
Change the numbers
and
in
then
that
the
page.
app is gonna kind of coordinate so that like, as long as they know, like what the app knows and the beacon knows, and they're the same, you just wanna make sure that they know. On both
Right,
sides.
yeah. So somewhere you have a database of these major and minors, right? So once you hit the cloud, you get a major of 1,000, you minor of 500, then your cloud knows where the beacon is.
They're resolved.
Yeah, so it's, yeah. So it's just, but, you know, you can just send one number and, you know, that database look up. Yeah, right. Right. It's just kind of, it works in,
All of these examples are about determining location by proximity, but there's a lot of other applications, so it's very much an application specific.
right. So, oh yeah, that comes out of the CoreLocation framework. Lets you determine the current location. Framework uses available hardware to determine user position. In iOS, you can also define a region around the Bluetooth beacon. So this is where the UID kind of comes into play. And the CoreLocation itself, so remember, you don't use CoreBluetooth to connect to these, you just use CoreLocation. You can have two different modes. You can have an event and you can have continuous scanning. So the event-based scanning is basically you have, so this is some code. You can define a region, and you can with proximity UID, so you tell iOS, I'm going to define a region with this UID, like the 128-bit number that we just saw, and then every time it sees one of those beacons, right? They can be in Paris, San Francisco, or whatever the other city was. Every time it sees one of those beacons, it wakes up your app. Right? So, well, it gives you an event, enter region and exit region, and you can actually run a little bit of code, or you can give a message to the user. The user can click on it, it opens up the app or something. So what you can do, so there's 3 different calls, and that's kind of where the UID mentioned do come into play. So you can also just say, well, to iOS, you can say, well, only look for the UID and the major. So if I have a major, if I tell iOS, look for major 500, it sees a beacon, it sees my beacon when it's major 501, it doesn't do anything. So you can, these calls, you can start them and stop them anytime you want. So you could, by geolocation, so if you find you're in a different geolocation, you just run on a different call or something. So there's some flexibility in that. Then once you start monitoring, right? So you can just start monitoring for regions anytime you want to. So if you're a good citizen, you don't monitor all the time. You kind of use those, because every time you call stop monitoring, it's going to start using some more feedback. So you can you tell iOS to start monitoring, then you get the event region to the exit region, and it tells you which region. So you can have up to 20 of these regions stacked up. So I can list 20 of them. And it tells you which one out of those 20 it actually found. And then once you're inside the region, so once maybe you go to a mall and there's maybe 200 beacons there or something, and the phone kind of woke you up and you're inside this region. You see maybe 10 or 20 at all time when you walk through the mall. You can start ranging for beacons in the region, and this is a continuous. So this uses even more value because this is continuous. Once a second, it gives you a, gives you data back. So start ranging. So it returns an array of all the beacons that are in the proximity. It also gives you, it takes those two numbers and it gives you an approximate, The other ones, enter and exit region, don't really give you, they don't give you a clue how close you are to the beacon. It just says, well, you enter this region, you saw a beacon. But then once you're ranging for beacons, you get the overlay, distance and everything. So, yes.
Well, then when you leave a region, is it just like a timeout, like you can see packets after, like?
The exit region?
So, yeah.
Yeah, right. So, yeah, it's usually, we've done some experiments, I think. That's pretty quickly, a few minutes or so. You walk away. I mean, you can kind of test it yourself. It's just you walk away from the beacon and you see whenever you get the event. And it's usually a few minutes.
10.3 seconds times your tolerance.
Excuse me?
Should be around 10.3 seconds times your tolerance.
Okay. Yeah. Possible.
Because your maximum window is 10.2 seconds. For advertising a beacon.
Right, yeah, because the advertising packets can be 10.2 seconds apart. That's the max. So you can, which, is not advisable. If somebody walks past it, you can lose some packets, right? You don't see them, and if you only advertise every 10 seconds, somebody walks, past your beacon faster than they can detect the beacon. So there's a lot of trade-offs. But, between battery power and discoverability. So iBeacon use those three numbers, and you can use a combination of those three numbers, and you can, tell the iOS to look for those three numbers. And what you do after that, right? So it just gives you a message, or it just gives you an event. That it enter a region, or it gives you a list of all the beacons. What do you do with all of that? Like, you put your coupon, or you send somebody a welcome message, or, that's totally up to the programmer. Right? Okay. iBeacon on Android, that eventually was proprietary Apple. So there are no libraries. There used to be libraries for iBeacon, but Apple made them, take it down. So, but it's not really that difficult to do. All you have is those three numbers, and spin up a background service and look for those three numbers. So, but you can't publish it anywhere. So,
So nobody's put it up on GitHub or anything?
Oh, yeah, they have, yeah.
Okay.
Apple made them take it down.
Or,
Yeah.
are the specs at least online? Or like,
Uh,
the stuff that we could talk about so far, the protocol and that?
Yeah, some of that. Well, I mean, so the UID image miner, that's in the spec. Yeah, so that extra number of the RSSI, so that's not in the spec.
You think that's why we never took off with proprietary Apple was so territorial within the industry, right?
Excuse me?
You think that's the reason why iBeacon never took off, because Apple was so territorial?
Yeah, possibly, but I think there's other reasons that people just, I don't know. I don't know if you're familiar, if you're in the iBeacon space, when it first came out, everybody said, oh yeah, it'll solve everything. And then people kind of start figuring out, oh wait, maybe it won't solve everything. And so there's still a lot of experimentation, what it's actually good at and what it's actually, like all the marketers were going crazy, oh yeah, now we know where everybody is and how many times they come here and we can just push coupons to everybody, and it's like, well, no, you really can't, right? You just piss off people. So they're really, which is actually, so there comes Eddystone, which is kind of cool. And so it was a Google initiative. They wrote the spec and stuff. They open sourced it, so it's all on GitHub. So you can use anybody. You can write your libraries, you can write anything, and you just publish it. And it was just introduced. It was introduced it's a little more than a month ago. And so the spec itself has 3 frames or formats, and so it's basically just kind of a spec. So one of the frames actually has code on GitHub already where you can use. So maybe Eddystone's going to take over the iBeacon world. It's because you can put it on your iPhone as well, right? So we have 3 frames. Two main frames on Eddystone. Frames is basically just a different mode that you can put it in. But the first one is Eddystone UID, and UID is just basically a copy of iBeacon. So instead of 3 numbers, you have 2 numbers. You have a namespace. The namespace is similar to the UID, and there are some instructions how to convert the UID into namespace, because the UID is only 28 bits and the namespace is smaller, so it tells you which part to take out, and it becomes a namespace. And then you have an instance ID. So instead of major or minor, you just have 1 number, and you can do whatever do with it. Maybe it's like a record number in a database or something, or you can just do whatever you want to. So there is, or you can split it up into 2 3-byte numbers or something. You can still have the 3, you can still have major, minor. So, there is no inherent support for Android, so Google, kind of put the spec out, but they don't really want it to be a Google exclusive project. They want it to be everybody to participate in the project itself. So I'm guessing there's going to be, by now there may not be stuff on GitHub, but I'm sure in a few months there's going to be a bunch of stuff. Everybody's events. Some people are going to write stuff and they're going to put it on GitHub so they can write it and publish it. So it's really similar. I have the advertising data. And the first one is 216, which is the same thing. Then the next one, it also, remember the iBeacon uses the Apple manufacturing packet, right? So in the advertising data, it actually said, well, anything after this is specific to Apple. Well, Google didn't do that. So it actually can generate a new service, which is not just open for anybody to use. Right. So it has to do 2 things. So first, it has to define the service. So it actually is service. And the service is FEAA. So FEAA is going to define FEAA as Eddystone service. And then after that, so each service you can associate service data inside the advertising package. Anyway, so you can just put some extra data to the service, and that's basically what they did. So there is a little bit more setup to do it this way, but then it's open source, so then everybody can use it, and it's not really Apple specific, Google specific. So, but similar to that, I have the specific data, which is, so I have another scanner that scans for Eddystone, and I have a namespace, and I have an instance ID, and you can see in the advertising data that there is a namespace, and then there is the instance. So it's probably similar to iBeacon protocol. And actually, they do have the same upgraded TX cloud. So it's not IPA. So we do have it's the same number, just like iBeacon had the last number. They put it up front. Well, first, Yeah, the frame type, which is UID, and then calculate as well. So the next one, which is interesting as well, so they have, so Eddystone defines rule, with Eddystone defines UID frame, right, which is similar to iBeacon. But then they also define this frame, which actually came first. This one was actually released as a iBeacon. If you're in that space, that means something to me, but if you're not. And so this, the URL was actually released like last October, so almost a year ago. And it was a GitHub project as well. But there's some apps out there, both on the GitHub project. There's an Android and an iOS app that scans for these types of beacons. And then once they release Eddystone protocol, they put the URL into Eddystone as well. So anyway, so instead of numbers, it uses a URL. So I don't have a number, so I have it's basically a URL. And in the advertising packet still, it only, it says 31 bytes out every second, half second. And same thing here, it's still FAA, so it's still an Eddystone service. But then the frame type, this number says in the URL, still have the cat or the TX power. And instead of just numbers, the last set of data is actually a URL. And you have this URL, http://fly.net and a number.
So this is what the beacon is advertising? It's
Right.
setting up this URL?
Which is,
So when you walk your phone. Oh.
yeah, right, yes.
Wow.
Yeah, so it's just added as URL. So there's only 31 characters, right? So you can't like have a URL that goes like deep /
Yeah.
whatever it's so,
Drive people to your blog.
yeah, definitely, right, yeah. So with the, most people will use like the URL shortener.
Right, yeah.
And then the problem solved, right? But still, and it'll be, yeah, so these numbers here, so this is actually, well, if you're into ASCII or whatever, so this is 6B, 4B, it's actually right on that. And, there's some schema that you can actually, so you don't have to use HTTP ://www. That's actually just a 0. Actually, this one is a 2, so it's just HTTP: / since I don't have the www. So it kind of truncates. So you do have a little bit more space than just, I think it's 18 characters that you get one after all of the other characters. Yeah, I think you have like 18 characters left or something. And with some shortening things like the .com, you can also shorten those as well. Like the 03 means actually .net. So I didn't really have to type in .net. So anyway, so.
Does it always expect the last character to be .com or .org? Because what about the new top level domains like .party?
Yeah, then you have to, no, it's only a set, it's a set it's a set of 5 domain extensions, maybe 5 or 6. Yeah, otherwise it just has to spell it out. So use more characters. But then you can use it, you can use it in range shortening, Bitly or the range shortening for Eddystone else. Yeah, so probably mostly yeah. So yeah, so Eddystone URL used to be iBeacon, and it was announced as a physical web about a year ago. And it's and the big tagline was it block up and use anything, right? You just in the browser, it's just a URL, so you can stand in front of Mona Lisa and the beacon advertisers just sends out the URL for the page in the museum that brings you right to Mona Lisa. Right? And so, but the other thing was that both the iBeacons and Eddystone UID, so they're both kind of similar. And the thing was that they use apps, right? And so Yeah, these apps, so you're gonna have like an app for, you know, for everything. You have an app for target, you have an app for, so to really to work with iBeacon, you have to have like apps for everything that you want to work with.
Yeah, like in Starbucks, we want the Starbucks, little Starbucks icon on your, the bottom home screen.
Right, yeah, you have to have the Starbucks app.
Yeah.
Right?
Yeah.
So you're gonna like install hundreds of apps, just for, you know, to see all the beacons, so if you want to know something, you know, install it, it's, you know, it's.
Don't you think you want to opt into that?
Well,
that's
our fun.
Well, actually, the Eddystone, the URL it's not a push, it's always a pull. So that's another thing we have. It's kind of smart, so you don't, I'm gonna get into, so, but Eddystone URL does not use a browser, you know, does not use an app, a browser, but of course the browser is an app as well. You can still make your own apps. There's two open source apps that you can download to scan for Eddystone URL, and you can adopt to your own thing, so those are already out there. Right, so, actually, yeah, so right now, on your phone, if you have Chrome installed on your iPhone, you can scan for Eddystone URL beacons. And in your today screen, you can actually, it gives you a list of the beacons around you. And so there's no other problem, yeah. Not all app developers, well, everybody's an app developer, but you don't need an app anymore, so.
Unless you're on iOS, right?
Unless you're on what?
Unless you're on iOS.
No, this is iOS. Well, yeah.
Well, you just have to assume that everyone has Chrome installed in their iOS.
Right,
Which they don't.
No, they don't, yeah, right. So maybe, yeah, and this was just the first steps, and actually they don't have it on Android yet, so you can install an app too, that scans for all the, you know, for all the beacons, but, well, we'll see, it just came out, you know, so we'll see where it's gonna go, but, yeah. You can't really install apps for everything. So maybe you're still gonna have dedicated apps, so like if you're a Starbucks fan or something, you're still gonna have the Starbucks. But if you do go somewhere, or maybe, you know, different country or something, you don't really have to download the app, and you can just connect, you can just use Chrome or something. And I'm guessing this is probably gonna be an Android as well, eventually. And somewhere else, so. Yeah.
6.
Yeah.
Anybody know if Cordova has a hook for this?
Excuse me?
Anybody know if Cordova has a hook for this?
I haven't looked, but surely somebody's written it.
Sure.
Well, there was really nothing built into iOS and Android.
So there's no low-level service?
No. Yeah, no, they haven't built it into Android yet.
So you'd have to write the.
You'd have to write an app and then-
The hook for Cordova.
Right.
Yeah. But it's open source, so somebody's gonna have to write a little service and everybody can use it.
Right.
Well, once they put it into, you know, I'm sure they're gonna put it in Chrome on Android, which they haven't done yet. But once it's, I guess it's in Chrome and Android, most everybody has Chrome and Android. The low level service will all be there.
This, yeah. Gotcha. I don't even know how to use Chrome to do it.
I don't know how far they're gonna take it on Android. Just, you know, they just start.
I guess you install a Chrome.
And then iOS, it's,
See,
I don't know why it chose iOS first, but interesting. But there are two apps out there, one for iOS. You can use. I guess some of the problems with iBeacon or any of them really are Well, it's one of the things though, with this, so it's a full service, right? So you always have to refresh, you have to manually refresh. Messages don't get pushed to you. So, obviously you have to, well, first you have to install Chrome, then you have to enable this into today function. I'm sure nobody uses it right now. So some of the problems with iBeacon though is just sending out the numbers, so these iBeacons just send out these 31 bytes, and as you saw, I can look at the traffic coming from that beacon, and I can just send out those numbers myself as well, right? So I can make an iPhone into that iBeacon, and I can send the same number out. So if I have Starbucks or something. Maybe Starbucks pushing a coupon if you go into that store. Well, I can just take those numbers and push them somewhere else, and I get a coupon even if I'm not at Starbucks or something. So there is really no security because you don't connect to the beacon. So just data that's being sent out. Yeah. Actually, there was a mention in the press release for a third frame at the Eddystone, the ephemeral frame, that mentioned something that's going to take care of some of the security things. Yeah. I think that's about it. I can go with some Android code, or anybody's interested.
Yeah, I think that'd be great.
Okay. Yeah. So.
You know, Tom. You always take on about half hour into it.
So I did do some previous work, but Android Studio Google, Android has a project called Bluetooth LE So you can just download that, or Android Studio, you can get it. And if you compile it and you run it, you get a list of Bluetooth or any devices. Now how to get actually the data for the beacon itself. Well, you have the device scanner. So then actually, the project itself, you can connect to. You get a list of devices, and then you can connect to devices as well. So really, the only part you do need for this device scanner is just scanning for devices, right? With device scan activity, I'll create your, obviously first you figure out that Bluetooth or energy is even supported on your machine, right? It is something new to phones. And so then once you figure out Bluetooth support, and you get the Bluetooth adapter, and you get the Bluetooth manager, and you get the Bluetooth adapter. And this is all code that, like ports into the project. And then on resume, this particular project immediately starts scanning for beacons, right, or for Bluetooth energy devices. which beacons are Bluetooth devices. So you can, of course, you don't have to. You can have a button or something to start scanning. But this is basically Bluetooth adapter is enabled. If it's enabled, if it's not enabled, then you post a message to the user, will turn it on. And then finally, it's scan for low energy devices. To start scanning for low energy. So the Bluetooth adapter is built into Android, right? So you don't have to. It's just a second. And scanning for devices. It's basically, so that the Bluetooth adapter, as it's called, it's deprecated, but it's on. It's just a different form, they're still, so it's start scan, I think right now with 2 more parameters instead of start having scan. But you can start scan, and in this case, they're setting up a callback to stop the scan after 10 seconds, which saves battery. So you just want to scan for a little bit, see what's around you, and then stop scanning. So once you tell the Bluetooth adapter to start scanning, you give this a callback function, right? So it then calls you a callback function. For each device it finds, it gives you a callback, right? And so in here, if I can actually bring my Nexus 7 that I can plug in. Now, I haven't really checked it yet, but
Nothing ever goes wrong in lab demonstrations.
you want to know, yeah. I haven't checked if the simulator, if you can run it in the simulator, if the simulator uses the Bluetooth chip on your computer. Apple used to do it. You could actually run the simulator, but they stopped like a year or 2 ago. They don't. So anything you do with Bluetooth, you have to run it on the on the phone or on the tablet or something, because it does use the hardware to do it. So it's all right. So if I do run this on my my Nexus. So now it obviously installs, and you've seen that it immediately starts scanning for Bluetooth devices, and it found one, right? So it stopped here and it found one of my devices. And so now if I look at the scan record, so the scan record, so it does have a class called Bluetooth device, and it picks up the name, and it Android goes over the services and kind of parses some things, and then gives you all of this stuff back from the device. And of course, with the Bluetooth device itself, you can then use it again, or well, it's an instance of a device. And if you want to connect to it, you just use the Bluetooth device to connect to the device. But as far as iBeacon and Eddystone and all of the other ones, which everything is in the advertising packet, but it also gives you the RSSI, but everything is in the advertising packet. So the interesting thing is the scan record for us, for iBeacon stuff. And the scan record right here, down here, if I can turn all this into X. It's basically what we saw in the advertising pack, right? So 1A, that was for the Eddystone, not the and so then you have 4C, FF, and then I have the frame is I guess the frame type is UID, and and then I have the namespace, and then I have the number and stuff. That you have. Now, of course, parsing all these numbers out, so, well, you can't just go, well, okay, this is 2, so I can forget about the next 2 numbers, and this is 14 long. I can check these numbers out and see if you can kind of parse those out. And see which beacon you post to, or which URL beacon is actually broadcasting. So there's really not a whole lot to it. I did mention that there's some sample code out there for physical web. So there's actually an Android project and then an iOS project. And then an Android project has source code in there that parses this for you. So you can go there, grab that code, and you don't even have to parse the scan back, and it just gives you back the URL. Well, actually, no, the UID and the namespace and stuff, that's not for you. So it's just for URLs, for Eddystone URL. But, yeah. So if I hit go, it should be the next one. Yeah, so this is the next beacon. I have 2 beacons here. Actually, there's more Bluetooth devices. So some of them, actually, some of them are not going to be Bluetooth, some of them are not going to be beacons. So you do have to go check for the right numbers to be in the right sequence. So right, number 6 and 7 have to be in the area, have to be those numbers and so on. But that's basically it. Then you can do, so you know the place for this URL, or you can open up the web page. Yeah. Let's have a short demo.
What do you see as the best use case for beacons in the near future?
Yeah, that's a good question. That's what everybody's trying to figure out.
Yeah, tell me and then I can go do it and make lots of money.
Yes, yes.
Maybe a different question. What are have you ever seen some cool use cases that aren't just you're here, you're in front of a Mona Lisa, or you're in front of something I don't know, an alternative use case?
There was a place recently that used beacons to have a URL. I guess the majority of it was just getting it to the web app, but it was a web app that allowed you to control a series of Christmas trees with lights using buttons. So everyone in the conference room was getting that URL and going there and controlling the lights all around the room. The initial thing was just using the URL, but getting to the web app is quick, so everyone can participate. It's fun. So.
See anyone use these for nefarious plan deal?
They will.
Yeah, that's.
Well, seeing as they're all advertising and not really gathering.
No, yeah.
And that's why
The URL one,
you have to get it yourself.
Because if apps like auto open just any URL, they have to be.
I mean, if you have an app on your phone that does something with the beacons, that could be susceptible.
But it doesn't automatically pop up in, that's what I was wondering. It doesn't automatically pop up in browser and shows you whatever it wants to do.
Well, that's the vulnerability if you have an app that does.
One thing that I saw online was I can't remember the site. There's at least one website where they're trying to index where. So if you open up the scanner, you can walk around and it'll take your GPS and say, oh, iBeacon 72 is right here in Nashville, and 86 is right here. And that, I know that was kind of the thing about security, why people were apprehensive about buying and deploying. Cities, for instance, wouldn't go buy 1 million iBeacons and deploy them everywhere because if somebody goes around with a little scanner and maps out where they all were, now all of a sudden the city can't monetize it anymore, so their capital expenditure was not as nice as they thought it would be. So
Yeah, the security issues are what concern me the most.
With the URL is just another website, so there's no security issue. Because we already solved that problem. We solved ourselves the web, the URL security problem. Well, obviously not, but there's still, but then you can have like a login, right? So maybe, so you already visited Starbucks, I mean, you already have like a cookie in your browser for Starbucks. So basically, the browser just knows that you're close to that. So then you have to have security through logins with passwords and stuff. Which doesn't really tell you that you're like there to you, so. Yeah, there's I mean, that's why, that's one of the reasons why it's not everywhere yet. There's a lot of problems to be solved.
Can you talk a little bit about physical net? That's a Google layer, that's
No, that's.
or you're just saying generically you can go to anywhere it works with the physical, but you're just going to go to the physical net. Is that what that?
Are you talking about .NET or the physical web?
Just the web or?
No, up there on the slide, you talked about physical net.
It's just the web. Yeah.
I think
There's fine on that, yeah.
the physical web is just basically a concept. It's just the idea of,
I took that to mean like by browsing, physical web, is that what you mean, by browsing? That's what I.
Yeah. Well, yeah. They just call it physical web, I think, yeah. It's kind of a, yeah. So then there's the, the IoT, the Internet of Things, which just it's not as well.
Yeah, that's true.
all right, if that's it, then